In this screencast, you will learn about Xcode, which is the main tool for iOS app development. It's an integrated development environment, which means we use it to write code, to run our apps, and to test them. When you open Xcode, you get presented with the splash screen, and that allows you to create a new project or open an existing project. For now, we're going to choose Create a new Xcode project. As soon as you choose to create a new project, you see the splash screen here that allows you to choose from different templates. Make sure whenever you create an app that you actually select an iOS app template and not an OS X one. In most cases, you also want to use an application template. On the right-hand side, you can now see the different templates that Xcode provides that are good starting points for different kinds of apps. For most applications, and for both of our tutorials, we're going to use the single view application template. It creates a blank storyboard that only has one view controller and source files associated with it. Let's select single view application and get started. On the next screen, you have to choose a product name. In this case, we're just going to call it Test Project. You can also choose organization name and organization identifier. Both of them will be added to most of your source files. Here you can choose the language that you want to write in, which will be Swift for our projects. You can select the device types that are supported. In general, we leave this at universal. And you can choose if you want to use the core data framework, which we won't do for now. After you completed all these settings, you can hit Next. Now you can choose a place for your project. And finally, after you create, the project is created. As you can see, the default project comes with a bunch of files already created. This view on the left is called a Project Navigator. It lists the different files in our project and allows us to select them and view them. Each of these different file types has a different representation. For example, if you select a source code file, we see the source code. If you select a storyboard file, we see the overview of the view controllers that we added to that storyboard. If you select a project file, we can see the different project settings. You can also see that we have groups that these files are grouped into. One important aspect about Xcode is that these groups here don't necessarily represent folders on the file system. To find out where a file is actually located on the file system, you can right-click onto a file and select Show in Finder. In this case, we can see that the app delegate is inside of the test project folder. In this case, the file is actually in the correct folder and it matches our group in Xcode. Let's see a different case where we create a new group in Xcode and the file system and the groups don't match up. To create a new group, we can right-click into the panel or on any folder and select New Group. You can see we're now creating a subgroup within the test project group. Let's call this Code. And now we want to add a new file to this group. To add a new file in Xcode, you need to go to the top menu and select File New. Make sure that you have whichever part of the project selected where you want to add that new file. In this case, we want to add it to the code group. So select the code group and then select File, New File. In this pop-up, you can see a selection of source code file templates. These help us to create different types of source files. In most cases, you want to select iOS, source, and then Cocoa Touch class. With this template, we can choose a superclass and a class name. Let's say we want to create a user view. Then we select the superclass to be UI view and the class name to be user view. After we have selected this, we can choose Next. Now Xcode will ask us where we want to store the source code file. As you can see, we don't have the code group as a folder on the right-hand side. Groups created in Xcode do not create folders on the file system. So for now, we're just going to create it within the code group, but within the test project folder. So group and folder don't match up in this case. Let's hit Create. Now you can see we have created a new class that is a subclass of UI view and comes with some template code, depending on the superclass. But as I mentioned, we have a problem here because the code group doesn't match up with the file system. And that can end up in a pretty big mess, where all the files in Xcode are nicely organized, but in the file system they're all just in one folder. So how do we solve this problem? Typically we want to create the folders for each group separately and then add them to Xcode. So let's say we want to create a new group called views. The right workflow for this is to select the project, right-click onto it and show in Finder, and then create a folder that we want to add to our project. In this case, the views folder. Then we go back to Xcode, select the level where we want to add this folder, right-click onto the folder, select Add Files, and then select the folder from the file system, in this case the views folder. Now we have added the views folder, and we have also correctly added a group for it. The group and the file system match up. And if we create a second new file now, it will be created within this group and within the correct location on the file system. Let's say this is an account view, also a subclass of UI view. Now you can see that Xcode suggests a views folder that matches the views group. Let's select Create. Now we have another new file, and if we right-click and show in Finder, we'll see that that new file is within the correct folder that matches the group in Xcode. When adding new groups to your project, you should always use the second workflow that I just showed you. First create a folder, then add that folder to your Xcode project. Now let's take a look at some more features of Xcode. One of the most important features that you'll use often throughout development is search, both within files and for files. When you're inside of the code editor, you can hit Command F to bring up a search bar at the top. Then you can search for certain terms and it will be highlighted. By hitting Enter, you can switch between the different occurrences of that search term within the file. If you want to search for different files, you can do that in the left panel in the Project Navigator, using the search bar here at the bottom. However, be careful to actually reset this when you're finished. Otherwise, you will be wondering where all of your project files are. A third way to open files is using the Command-Shift-O short key. It will bring up a little pop-up that allows you to search for different symbols, such as class names. As soon as you start typing, you will get a list of auto-completion suggestions. Typically, the first results will include the files in your project. By hitting Enter, the file will be opened. This is very useful for quickly navigating between different files in your project. Now let's take a closer look at the actual editor, because that will be one of the parts that we'll be using most when writing code. Firstly, Xcode has a very useful auto-completion feature. For example, if you're in a view controller and you want to implement the viewWillAppear method, then you will get some useful suggestions of which methods you actually could use here. This is helpful both when typing to save time, but also when you forgot how a method is actually named or which parameters it has. Just type the beginning of the method and Xcode will auto-complete it for you. And if I want to implement viewWillAppear, I select it here and then hit Enter. And Xcode will add all the boilerplate code around it, for example, the override keyword and the function keyword, and will let me type code immediately. Additionally, Xcode provides useful access to documentation for our methods. By option-clicking onto different symbols, such as method or class names, hold down the Option key and then select a symbol in the source editor. This will bring up the documentation immediately. Reading documentation for such methods is extremely helpful and can save a lot of time when you run into issues or wonder how to implement certain features. This quick look feature also works for variables and content in our app that we created ourselves. Let's take a look at a little example. Create a variable and assign a value. And Swift allows us to omit the type in this example here. It can find out the type by the value that we assign. In a more complex statement, we might wonder what the type of A is. So we can option click onto it, and a quick look will tell us that A is a type integer. And there's some more cool features inside of the Xcode editor. To use them, we'll need to write some code. So let's assume we have a function in the account view called showAccount. For example purposes, it doesn't take any parameters and doesn't return anything. Now, we maybe want to use this function within the view controller. So we create an account view and assign this to a variable. And now we want to call a method on it. So we type account view, and then we get a list of potential methods. One of them is our showAccount method. Now what will happen many times is when you read code, you might want to jump to the method that you're calling here to check out some implementation details or to modify the code behind it. You can jump to different symbols by holding down the command key and selecting the symbol in the source editor. I hold down command and then click onto showAccount, and Xcode will open the account view and select the showAccount method. That's a really easy way to jump to a function, to edit it, or to check out its implementation. And if I want to go back, I can use the back button here on the top to jump back to the place where I was earlier. Xcode keeps a history of jumps between different places. That way I can also move forward and back again. This is again a very useful feature when navigating between different parts of your code. But Xcode provides even more navigation methods that we haven't discussed yet. Another very useful one is the breadcrumb view. In the top bar here at the top, you can see which file, which group, which project, and even which symbol is currently selected. Which symbol means the method that we're currently in, or the variable that we're currently looking at. By selecting this outline here, you get an overview of all the symbols within the view controller. If your class becomes really large, you can see all the methods listed here. These can be 20 or 30, and by selecting any of them in the list, you jump immediately to the location inside of the source file. If your code gets really large, which we typically try to avoid but cannot always, you can also add markers to different sections. Markers are created using comments, together with the mark keyword and a colon. And these markers can be named. For example, I can name the section here View Lifecycle Methods. If I have such markers, then the breadcrumb view becomes even more useful. I can open it, and I can see different sections of my source code, and will make it even easier for you to parse larger source files. So now we have covered enough of the editor to actually move on and look how we run code using Xcode. The most important part for running code is the selection up here. Firstly, the play and the stop button, and secondly, the selection, where we can choose the active scheme. You don't have to dive into the details of that. In most cases, your apps will only have one scheme, so make sure that the application is selected in this case. Additionally, you can choose on which device you want to run. If you actually have an iOS device connected to your computer, you can select it up here and run your app on a physical device. Otherwise, you get to choose between different simulators that you can check from this list here. After choosing a simulator, the pop-up will close, and you will see the combination of which app you want to run on which device. As soon as you hit the play button, Xcode compiles your app, brings up the simulator, or starts the app on the device. Simulator should pop up automatically, and after a couple of seconds you should see your app launching. Here's our splash screen. And now we can see the blank app that we created so far. When you want to stop playing your app because you finished debugging or testing, you can hit the stop button and the simulator will be closed and you're back inside of your Xcode project. In most cases, you will run your app to verify that a feature that you just added works correctly, or to debug your code in case it doesn't. Debugging is really an essential tool that you need for iOS development and software development in general. So we'll spend the rest of the screencast talking about different features that make it easier to debug your app and to find solutions to the problems that you encounter during development. One of the first essential parts of debugging is the console. Xcode shows a console that displays all the output that your app generates while it's running. To show it, you need to go to the top right corner and select the middle view here. We'll bring up the console on the bottom. The left-hand side will be discussed later. The right-hand side here is the console. To actually see something in the console, let's add a little log statement. So when view.load runs, we want to print something to the console. We can do that with the print line statement. Let's just print out test. Now let's run our app again. It compiles, and when it completes, the simulator should pop up. And now you can see the output in the console. The test output that we generated here is now readable. So if you run into issues, it sometimes can be useful to add such print statements to see how your code is progressing and which functions are called after each other, or what the state of certain variables is. However, printing to the console is really just a very basic and primitive way of debugging your apps. A more sophisticated one is using breakpoints. Breakpoints stop our program and allow us to inspect certain variables at that time, and they also show us which functions have been called up to a certain point. As we'll see throughout the rest of the screencast, this is a very useful feature when debugging apps. There are essentially two different types of breakpoints. The first one is an exception breakpoint that basically stops your app as soon as it crashes. That is activated by default in Swift, and it allows you to see which lines are causing the crash of your app. We first going to demonstrate the use of that. To show the demonstration, we actually need to add some code that crashes the app. So we're going to add a function called printNumber that takes an integer that is optional and prints that optional integer by forcefully unwrapping it. Let's say we have written this horrible code and we always assume that a has a value even though it's an optional, because we know that everyone who calls this function will always provide us a value. And now, somewhere else in our code, for example in view.load, we call the function and actually pass nil. So now we're passing nil here, and here we're assuming that a actually has a value. So let's see what happens. We run the app, it compiles, simulator shows up, and we see a crash. And this is what a breakpoint looks like. In this specific case, it's an exception breakpoint. We can see some information, very cryptic information about what went wrong, and a little bit more useful information in the console. Fatal error, unexpectedly found nil while unwrapping an optional value. So let's assume the code here is more complex than it actually is, and we don't really know who called print number and where this value is coming from. One of the first useful information that we can see when hovering over here is that a is actually nil. So now we know that someone has passed us a parameter that is nil, even though we assume that we can unwrap it because it always has a value. So whoever has called this function has actually made a mistake. So if you want to see which function has been called before this one here, or which function has called this function here, you can go to the left and take a look at the stack trace. The stack trace shows all functions that have been called after each other. And it currently highlights the function we're in at this point in time, where our execution of the program has stopped. If we want to go back one function and see which function has called the current one, we can click down one row below in the stack trace. Now we jump to the calling code. In this case, it's inside of view.load, this call to print number that is passing nil. So in this case, we have identified that the issue is here in the caller not passing a value. It's a simplified example, but it shows you how to debug code. First, take a look at the line that is crashing. Inspect the values. You can see a is nil. Another way to inspect the values is taking a look at them down here in the debug inspector. You can see a has a value of nil. You would also be able to see any other variables that are passed to this function or any local variables. And additionally, you can inspect all the properties of self or any other objects by expanding the view here. We won't discuss this feature in detail right now. After you have identified which variable has the wrong value, in this case a, which has nil, you can analyze the code and see if this function itself or any calling function is responsible. In many cases, the problem won't be inside the function, but actually in the function that called this function, or even further down the call chain. In this case, we can see that this code here doesn't really do all that much, so the problem must have occurred earlier. As we saw earlier, we can go back into the stack trace and select the function that has called this function to inspect it. So we have identified that our issue is here. Let's stop the application to fix the issue and then run it again. So instead of passing nil, let's pass a number. Okay, now the code should be valid. Let's run and see what happens. Now we saw the simulator pop up and Xcode is freezing. And something still is wrong here. We again have an error message. And when I look at the stack trace, I can see that we have a lot of more calls going on than earlier. What is happening here? Let's go down the stack trace and see which function has called A, because apparently the value here is fine, so I wonder what has happened before. If we go down the stack trace, we can see that this function has been called by itself permanently. That's because of a small error that slipped into this line here. We actually didn't want to call print number, but we wanted to print the number to the console using the print line function. So let's fix this. Okay, now it's again time to stop the app, to run it again, and see what happens. Now we can see that 2 is correctly printed to the console. Exception breakpoints are really useful to debug why your app is crashing. However, in many cases, your app will not crash, but it still doesn't work correctly. Then you will have to use regular breakpoints to decide to stop your app at a certain point in time, at a certain method call, and then inspect values to see what is going on under the hood. I want to show you a little example of how to use regular breakpoints. Therefore, I've extended a count view. It now has 2 properties, A and B, that store a value of 10 and 20. And I've also extended the showAccount function. It now increases the value of B by 10 every time it is called. Now let's assume the value of B is not correct. It's not the value that we want to have after we have called showAccount. How could we inspect this? So inside of viewController, we're calling showAccount at this line. This is the line that we want to analyze in more detail. So let's set a breakpoint here so that our application stops when we reach it. Then after we set a breakpoint, by clicking into the line, we hit the play button. Now the application started and it stopped at line 34. Now we have time to inspect values. And here on the left in the debug inspector, we can see all the values that are currently available in the scope. One of them is the account view. And that is the value that we want to inspect further. So right now, the account view has a value of A that equals 10 and a value of B that equals 20. And account view.showAccount has not been called yet. By setting the breakpoint on this line, the program stops before calling this line, before performing the action on this line. So now if we want to see if the value behaves correctly when showAccount is called, we can step over this line by clicking onto the symbol over here. So let's step over. The instruction is now performed, and we can see that the value is updated correctly. B has been increased by 10 and is now 30. Now that we have confirmed that, we maybe want to continue our program. So instead of stopping execution, we want to play and let the app continue regularly. We can do that by selecting the Continue Program Execution button here. Now the program will keep on running regularly, and will only stop again if this line of code is called. Since its view will appear, it won't be called again until we stop and restart the app. That is how you set basic breakpoints and inspect variables. There are 2 important things to note. Firstly, I'll restart the app to show you them. It's very important that whenever you are in a breakpoint, you are within this view over here, called a Stack Trace Debug Navigator. That will allow you to actually see the methods that have been called. If you're in any of the other inspectors, you won't have the benefits of seeing the stack trace. Typically, Xcode activates this debug view per default, but it doesn't in all cases, so make sure you have it selected. Secondly, it's very useful to turn on line numbers in Xcode, as I have here. You can do that in Xcode, Preferences, Text Editing, Show Line Numbers. That will make it easier to communicate with instructors and talk about certain lines that cause problems. Once you're finished debugging your issue, you will want to deactivate your breakpoints. There are two different options to do that. Firstly, here in the bottom left, you can temporarily deactivate breakpoints for your entire application. This means your app won't stop in any of the given breakpoints. That is indicated by all breakpoints being grayed out. Alternatively, you can take an individual breakpoint and drag it away from the line number. Then that breakpoint will be destroyed. Awesome. This covers the most essential part of debugging. I showed you how to use exception breakpoints, how to use a stack trace to go back up the call stack, how to set individual breakpoints, and how to inspect values. There's one new cool feature that has been added to Xcode recently, and it allows us to debug different views. So let's, as a last step, take a look at that. I'll open a storyboard and add some very simple views so we're able to test this feature. Let's add a button, a second, and a third button. Now we can run this application, and we should see some elements on the screen. As you can see, they are not layouted correctly. You'll learn more about that in the auto layout session. So this is what our app looks like. If there are any issues that you can't easily figure out that are related to views that are mispositioned somewhere on the screen, then you can use Xcode's View Debugger. You can do that by pausing the application that is currently running with the pause button here on the bottom, and then selecting the debug view hierarchy. Then on the left-hand side, you will want to select the window of your current application. Now you get a separate view where you can zoom in and rotate your view to take a look at the view hierarchy and inspect it. In this example here, we were maybe wondering why the button is not rendered on the screen. The underlying reason is that it doesn't have any constraints set up, and we'll talk about that separately. But what you can see in this debugger here is that you can even see elements that are not rendered on the screen, like this button over here. So if you have issues in your view hierarchy that are hard to debug, take a look at a view debugger. It will often help you. For now, we have covered the most essential features of Xcode. You have learned how to manage files, how to search, and most importantly, how to debug your apps.